Hi, my name is Brandy Heflin. I'm a personalized physics instructor and I help high school and college students feel confident and successful in learning physics. Since physics is a lab-based course where all of the important relationships can be found by taking lab data and looking for patterns in the quantities that we've measured, I wanted to take a few minutes today to teach you a little about significant figures and experimental uncertainty and how those ideas are related. We're going to use a simple greeting card envelope as our example. You've probably memorized rules for handling significant figures in chemistry, but you might not have heard about experimental uncertainty and propagation of error, so I'm going to talk to you about how all of these things are related today. The number of significant figures you can report in a measurement is related to the experimental uncertainty of that measurement. So what does that mean? Each measurement you take has an uncertainty based on the smallest division on the measuring tool you're using. As an example, a stopwatch usually is subdividing down to hundredths of a second. So we would be able to say that the hundredths place is our least certain digit. You can measure precisely to the nearest marking on the tool, and then you have to estimate the next place if the object is in between markings, and that really applies for distance measurements in particular. So here's that greeting card envelope from earlier with a ruler laid on top of it. Notice that the smallest division on our tool is a millimeter, so the most certain digits we can record are in the millimeters place. If you notice right here at the edge of the envelope, it falls right on one of those millimeter markings. So we can report this as 20 centimeters, and then we can count out 8 millimeters beyond that. So that would be 20.8 centimeters for our certain digits. And since we have that edge right on a marking, we're going to call our final uncertain digit 0. If it turned out that that edge of the envelope were in between the 8 and 9 millimeter markings, for example, we could then estimate that uncertain digit. We know it's 20.8, and if the edge were closer to that, we could say 20.82 or 20.83 centimeters is our value. If it were a little bit further over and closer to the 9 millimeter marking that comes after 20 centimeters, we could call it 20.86, 20.87, or even 20.88 millimeters. Centimeters for our answer. And actually, we should go ahead and put units on our answer as well. So the places that you can actually measure precisely with your tool are your certain digits, and the place that you have to estimate is your uncertain digit. The correct number of significant figures to report is all of your certain places plus no more than one uncertain place. Our example here has 3 certain digits plus 1 uncertain digit, so we could report 4 significant figures. So we just saw that the length of our envelope is 20.80 centimeters. And in fact, when we measure the width of the envelope, it comes out to 13.8, and then we have to estimate our final place, and I chose to estimate it as 5. So 13.85 centimeters is the width of our envelope. We now can use these 2 dimensions to do some calculations. When we're doing calculations with values which have uncertainty, the result of combining a certain digit with an uncertain digit is now itself uncertain. And this idea is called propagation of uncertainty or propagation of error. So here's a quick example to show propagation of error. We're going to arrange our input values as needed for the mathematical operation. In this case, we'll find perimeter and area, so we will add the side lengths of our envelope and we will multiply them. We're going to circle each uncertain digit, and then as we complete the steps of our mathematical operation, we're going to circle each digit that's the result of combining a certain digit with an uncertain digit. And then at the end, we'll keep the appropriate number of significant figures with no more than one uncertain digit. So recall that perimeter is what we get when we add up the lengths of all of the sides of a figure. So we can take our 20.80 long sides of our envelope and our 13.85 short sides of our envelope, and then add them together like this with 2 of the long sides and 2 of the short sides. Notice that all of my uncertain digits have aligned vertically, so I'm going to expect that only my final value or my final number in that last place will be uncertain. And when I go ahead and add all of these up, I get, oops, that should actually, I'm reading right to left. Got a little confused there. So I will get 69.30 centimeters as my perimeter. And following the rule I just talked about, with combining uncertain digits yields something uncertain, we will expect our final digit to be our uncertain value. So we can now report 4 significant figures that's made up of 3 certain values and 1 uncertain value. And another way to find perimeter is to take the length and multiply it by 2, and take the width and multiply it by 2, and then add those together, at least when we're dealing with a rectangle, square, or other quadrilateral. So let's go ahead and circle our uncertain 0 in the length and the uncertain 5 in the width, and then multiply each one by 2, and then we'll add those 2 results together. So when I take 20.80 centimeters and multiply it by 2, I get 41.60 centimeters. And we're going to expect then that since the 2 was multiplied by the 0, which was uncertain, that yielded this last 0 on the right. That's going to be our only uncertain value. When I take 13.85 and multiply it by 2, I'm going to get 27.70 centimeters. And likewise, 2 times 5 is our combination of uncertain digit with something else that is certain. We could say our 2 is certain. So only this final 0 will be uncertain. So now let's go ahead and add our 41.60 centimeters with our 27.70 centimeters. And again, let me change color really quickly. Let's go ahead and circle our uncertain zeros here on the end, and then we will add our 2 values. And when I add them, I do end up getting 69.30. Did the same thing I did earlier. 69.30 centimeters as my result. Let me go ahead and circle the final 0. That's my combination of uncertain digits. So again, we have 4 significant figures with 3 certain digits and just our final uncertain digit. Sorry, my end didn't turn out very well there. So let's demonstrate one more calculation. This time let's do area so that we can show a different way when uncertain values end up being combined. So I'll start by circling my 2 uncertain digits over here on the right side, the 0 and the 5. When I go through, I'm going to multiply, using the algorithm that we all learned in elementary school. I'm going to multiply everything in the top row by my 5 first. And here are the values I'm going to get. So, since this entire row was generated using that uncertain 5, every single digit in this first row is uncertain. And now when I move on to the 8, and I'll do my 8 in the 13.85 multiplied by everything in that top row, notice that only my first digit, my 8 times 0, which gives me 0, will be uncertain. And that's because this is the only one that combines a certain digit with an uncertain digit. Okay, so now to go ahead and circle my single uncertain 0 here. And next we'll go through with 3 multiplied by that whole first row. And once again, I end up with 3 times 0 gives me something uncertain, so that 0 is uncertain. And last but not least, we'll do our 1 in the 13.85 multiplied by everything in our top row, and I'm going to get 0, 8, 0, and then 2. And we're going to end up adding these, but not before I go mark. Once again, 1 times 0, that 0 is uncertain, gives me something uncertain. So now I can go ahead and do the addition to give me all of my values for my multiplication. And then my decimal point will go here. And so now we go through and we circle everything that was combined using uncertain digits. And that is my right 5 places. So I want you to notice something that happened here. Even though the values that we input had 3 certain digits and 1 uncertain for a total of 4 significant figures, we can't do 4 significant figures here because 4 significant figures would take 288.0. That's 4 significant figures, but that's too many because of that last 0. So in fact, we can only report 1 uncertain digit. So we're going to take our answer. In fact, let me write this down really quickly. 1 uncertain digit only. So we will report our answer as 288 square centimeters, because that satisfies having a number of significant figures that includes no more than 1 uncertain digit. As we just saw, we got a result with 3 significant figures rather than the 4 significant figures on the values that went into our calculation. And this is okay. We simply can't have more significant figures as a result of a calculation than went into it. We can consider how sensible is our result. So we can compare how big is this smallest piece of the value we're reporting compared to the overall value. So 1 square centimeter is about the size of my thumbnail, and we're going to compare that to the 288 square centimeters for our envelope. Would it really make sense to compare 0 point something of something the size of my thumbnail when we're talking about 288 square centimeters? It actually wouldn't. So a similar line of reasoning that you can apply in physics, especially when making distance measurements, is that you wouldn't report fractions of 1 meter if you're measuring something in the hundreds of meters, or especially even thousands of meters. I hope you found today's explanation of the connection between experimental uncertainty and the real measurements we can take in physics and significant figures like what you learned about in chemistry. If you'd like to connect with me further, you can email me at brandyheflinphysics@gmail.com. You can check out more about my tutoring services at brandyheflin.com, including testimonials and more information about my history and background. You can also visit virtualphysicsofficehours.com to get more information about my office hours style tutoring service, and you can find me on Facebook at Physics Tutor Brandy. I'm Brandy Heflin. I love physics, and I love helping you. Until next time.